طيب بسم الله الرحمن الرحيم. So in the transport layer we are going to discuss the basic functionality of any transport layer protocol, including first and foremost, of course, multiplexing and demultiplexing of multiple streams. As we have discussed in other networking courses, the main idea or the main function of transport layer protocol is to facilitate the end-to-end communication between two application endpoints. Two application endpoints, okay? Not two hosts, two application endpoints. One single host hosts hundreds of applications, okay? So one application on one host with another application on another host, the communication between them is facilitated through the use of transport layer protocol, okay? As part of this, the transport layer protocol needs to facilitate the multiplexing and demultiplexing of the multiple streams from multiple application endpoints. So if we assume that we have a host, this host contains multiple endpoint application. By endpoint application, I mean like browser tab, FTP client, FTP server application, things like that. Okay? Each application endpoint runs in a separate process or thread. Okay? So that's from the application perspective. Okay? From the network perspective, the network for us is just as like a big pipe like this, where it connects that host physically or logically with the network, right? In between here, we have the transport layer protocol. So the first thing that the transport layer protocol does is to facilitate the multiplexing of these streams to the logical network connection. Okay? And of course, the multiplexing at the receiver side becomes a demultiplexing. Okay? Demultiplexing is that when we have stream of packets coming from the network layer, that we can demultiplex these packets to the application endpoints. Okay? So what type of information or field in the transport layer protocol that I use to do this? Huh? What field in the transport layer segment that I use to assign a particular segment to an application endpoint? Huh? What? Network one. ايه ده وات؟ لا ما كادرس، احنا مش ما كادرس ده فيزيك، يعني ده داتا لينك لاير. احنا بنتكلم ابلكيشن ترانسبورت نتورك، ما نمشي ال ايوه كده. هنا بقى البورت نمبر. Okay, so we have source port and destination port, right? Source port is used for multiplexing, destination port is used for demultiplexing. واضح كده؟ Okay, so multiplexing and demultiplexing is the minimum requirement for any transport layer protocol. Any transport layer protocol has to have multiplexing and demultiplexing. If it doesn't have anything else, that's fine. So the minimum is to be able to process the source port and destination port. Okay? The rest, you can consider it optional. Some protocols they have it and some protocols don't have to have it. اللي هي بقى ايه؟ Reliable data transfer. Reliable data transfer, we're going to spend the whole lecture actually talking about reliable data transfer. So reliable data transfer talks about the fact that we need to provide some guarantees, because we say that the transport layer talks about the fact that I have one application endpoint. Okay, so this is application 1 and this is application 2. Okay, Each one of them runs on a host, whether same host, local host, or two remote hosts, that doesn't matter. In between, there is a big network. Okay? There is a network topology, routers, switches, things like that. Okay? So the transport layer is responsible to facilitate the communication between these two application endpoints through the network. Okay? Does that mean that the transport layer protocol needs to know anything about the network? No. No, it doesn't need to know anything about the topology or the physical connection of the network at all. Okay? طيب. Given that, how can I have some reliable data transfer in that context while I don't know anything about the network? Okay? So that's why TCP uses some kind of acknowledgement techniques in order to facilitate the reliable data transfer. Okay? And the acknowledgement comes from the application, from the receiver, from the receiving application itself. So we'll talk about this a lot today, about reliable data transfer. طيب. There is also a flow. طبعا, as I said, reliable data transfer does not have to, it's not mandatory for all transport layer protocols. For example, UDP does not have any reliable data transfer. Okay? Does not provide any reliability خالص. What is the difference? This is a key question. What is the difference between flow control, congestion control? First of all, flow control or congestion control, they do what? They try to do what? حد فاكر حاجة؟ Network 1?
Control the speed of something.
برافو عليك. Yes, control the speed of transmission. صح كده. This is the first part of the definition. Perfect. Okay. So both flow control and congestion control, the transmitting application or application endpoint tries to regulate the speed of when to send the packets. Right. طيب, what is the slight difference between flow control and congestion control? دي صعبة شوية. Okay, احنا قلناها في network 1 المفروض. The small difference between flow control and congestion control is both they regulate the speed of transmission, but with different purposes. Flow control regulates the speed of transmission to avoid overwhelming the receiver. Okay? So I want to make sure that when I communicate something to you, that you are absorbing what I'm saying to you. Okay? So I'm not speaking too fast that you cannot really listen to what I'm saying. Okay? So we have to make sure that these packets are not going too fast that the receiving application cannot even cope with that. He does not have a buffer to store even these packets. Okay? So this is flow control. So flow control regulates the speed of transmission from the transmitter side to avoid overwhelming the receiver. Okay? Congestion control does the same regulation for transmission speed, but with the purpose of to avoid congesting the network. Or in other words, overwhelming the network. Because these segments, they go through the network, right? Okay? So these networks, they have routers, switches, things like that. Okay? So I'm sending some cars from one location to another, and they are getting jammed in the highway. So all of them, they get in the highway and they cause traffic jams. Okay? So the network itself is congested. So فهمنا the difference? So this is the difference between flow control and congestion control. Based on, so each one regulates the speed, but using different technique. So we are going to discuss and analyze the different techniques used for flow control. Unlike by network 1, now we just mentioned the definition and that's it. Here we are going to really analyze how we do congestion control, how we do flow control, and some analysis related to that. يبقى عرفنا so the basic functionality for transport layer protocol facilitates the end-to-end communication between or end-to-end conversation between two application endpoints. It performs multiplexing and demultiplexing using ports, okay? And some transport layer protocols, they provide some level of reliable data transfer and flow control and congestion control. Of course, UDP does not do any of this. يعني data, while reliable data transfer, no. Flow control, no. Congestion control, no. So it can congest the network easily, okay? But that doesn't mean that UDP is really bad and nobody uses it. Actually, it's used. It's being used. But we'll talk about certain applications where UDP can be used, okay? Of course, the transport layer protocols can be categorized as connection-oriented and connectionless. And we talked about this. This is quite similar to circuit switching and packet switching in a way. So connection-oriented, like TCP, it has to establish a connection. Okay, so before communication, I have to first establish a connection between the two applications before we start communicating. Okay? So establishing the connection, as we said before, allows us to have some kind of guarantees on the traffic that is going in. First, that the segments or the packet that will flow into this connection, they will go in order. So that's why TCP, because it's connection oriented, it guarantees the order of communication and it maintains the order of communication, and we'll see how. Okay? So connection oriented, we have to establish a connection beforehand, before communication, where connectionless does not dictate any handshaking at the beginning to create any kind of connection, in which case, so you can just send the segments independently from each other, okay? So each segment can go in different directions, and there is no concept of establishing any connection, okay? So that's why any of you who dealt with some socket programming, there is server socket and datagram socket. Server socket is for TCP, datagram socket is for UDP. For server sockets, you have to first request and the other party has to accept. So this is part of the connection establishment. Datagram doesn't have to do this. For datagram, you just send right away. You don't have to establish any connection. Okay? So this is the summary of what we need to talk about in this chapter. So at the beginning, transport layer, we'll talk about transport layer services, and then we will discuss these concepts of multiplexing, demultiplexing, and so on. And then we'll get to some reliable data transfer later on. So the transport layer protocol, as we said, provides some logical communication between two application endpoints, as we said. And they do that using the concept of segment. The segment is the protocol data unit in the transport layer. They call it segment, okay? As we discussed in network 1, for each layer we have something called the protocol data unit, which refers to the unit of communication in this layer. Like for example, in network layer, we always talk about packets, okay? For transport layer, we talk about segment. In data link layer, we could talk about
data link.
In data link layer, we talk about what is the name of the protocol data unit in the data link layer. We call it frame. Okay. So this unifies part of the terminology. Whenever I say frame, you know which layer I'm talking about. Segment, you know transport layer. Packet, you know network layer, and so on. Type. So of course, the way that these segments are created is as we said. So for an application, or each application will generate some kind of data or information, some raw data. This data can be like a web page, okay? So it has like some text, hypertext, HTML, things like that. So this data will be stored in the application layer. Then to go to the transport layer, we have to divide these into segments. Okay, so we call this a segmentation. Segmentation, okay? So in the transport layer, we do segmentation, and then we transfer back each segment based on the protocol that we're talking about, whether TCP, UDP, and so on. ماشي كده? So when we send these segments, the receiver side, depending on whether we are talking about connection-oriented or connection-less, so when we send these segments, sometimes we have to number these segments. We say 1, 2, 3, 4, okay? Especially if we're talking about connection-less protocols. Why? Because for connection-oriented, we said that these segments will arrive in order, صح? Because of the concept of connection. But we will see that even for TCP, we still need some segments. We'll talk about why. ماشي? But definitely for connectionless, we definitely need to have some sequence numbers because these segments may arrive unordered and we need to order them. So we need some sequence numbers for these segments to be able to reassemble these at the receiver side. ماشي? طيب, for the concept of multiplexing and demultiplexing, so we have multiplexing and demultiplexing talks about the fact, as we said, that for the receiver side here, okay, the transport layer is responsible for demultiplexing the segments that are coming in to the specific application endpoint based على based على ايه again based على the port number. برافو عليك. Yes, based on the port number. Okay, so each application for us, or each thread of the application, has some kind of buffer. We call it socket. Okay, so this socket represents the buffer that all these segments will get stored so that the application can consume these segments and display it. Or ماشي? So this is the socket, and this is the process or the application endpoint or the service in the application layer. Okay, and the socket, as we can see here, the socket is between the application and the transport layer. Okay, which is the buffer that the segments get stored to so that the application can consume it. ماشي? Of course, demultiplexing happens here on the sender side. Of course, this stream comes from multiple applications, and we have to do the multiplexing. So for that, as we said, we need source port and the destination port. Okay, and this is the minimum set of fields in any transport layer protocol. We cannot have a transport layer protocol without these two fields. UDP has it, TCP has it, all kind of transport layer protocols, they need to have these source port and destination. Other fields, we can talk about them. That depends on what other services or benefits that this transport layer protocol can provide. For example, reliable data transfer or not, congestion control, flow control, things like that. ماشي? So the port numbers, they facilitate the multiplexing to the host pipe, which is represented by the IP address. ماشي? طب what is the difference between multiplexing and demultiplexing for the case of connection-oriented and connectionless? What is the difference between multiplexing and demultiplexing for TCP versus UDP? As we said, we have two types of sockets. We have the datagram socket, okay? And as we can see for the datagram socket, we initialize the socket by the destination port number only. So when we create the datagram socket, this is for UDP, okay? We create the datagram socket for UDP using the destination port number only. Okay, so this is the identifier of the socket in the case of UDP. This is the only identifier, which is the destination port number. Okay?
Because it is not expecting something to be returned back. So no need to give.
No need for acknowledgement. Not only that, no need for acknowledgement, and no need for connection between source and destination. Okay? for the case of TCP, because of the concept of the connection, the socket is identified by 4 different values: source port, destination port, source address, and destination address. Okay? So if you change any of these values, then we need another socket, basically, another socket buffer. But for UDP, the only identifier is the destination port only. Okay? Because there is no concept of connection. We don't need to have a connection between a source and a destination. All we need is just to use that for what? Whenever we go at the receiver, we use the destination port to demultiplex. That's it. We just need to find the proper application where we send the segments to. That's all. Okay? So when a host receives the UDP segment, it uses that destination port to demultiplex. Okay? So that's how it looks like. So if we assume that we have application P2 and application P1, both of them, they communicate with application P3. Okay? So here, for P1 and P3, and for P2 and P3, there is no concept of connection here. We don't have to establish a connection. Okay? So P2 can send to P3 at the same time that P1 can send to P3, and both of them, they get to the same socket buffer because it's defined by only the what? The destination port. واضح كده؟ But we don't have established connection between this and this or this and this. There's no concept of connection at all. Okay? So that's why these two applications can communicate with this application through the same socket buffer. واضحة دي؟ ماشي؟ So I don't need to demultiplex even to multiple applications because all of them, they will go to the same socket, and this socket is listened to by P3, so the communication will happen. But here, there is no connection. ماشي? So that's easy. So the only thing that specifies this is destination port here and here. As long as this destination port is the same, okay, they will go to the same socket. That's it. ماشي? Now on the source port gets assigned to each application endpoint at the transmitter. Like for example, if you open the browser and create a new tab, when you create a new tab, the operating system will assign a source port to this tab. If you add a new tab, the operating system will assign another source port and so on. So each tab on the browser, okay, will take a separate source port. Okay. But all of them can communicate to the same destination port, which means it will go to the same socket buffer as long as we're using UDP. The same بقى يعني إيه? The same context or this same configuration. If we assume that we use server socket instead of datagram socket, okay, this will be totally different. Because for P2 to communicate with P3, we have to establish a connection. So there has to be an established connection between these two. Established connection means that we have to use the source port, destination port, source IP address, and destination IP address. All the 4 values need to identify this connection. واضح? So that's why if we talk about the same thing for the concept of TCP, خلاص, every single stream or every single application that communicates with a process from here, they have to have some kind of a connection. Okay? So as we can see here, the destination port is 80, and here is 80, صح? But this means that port 80 is used for what? For web HTTP, صح? So even though the same destination port is used, but here I created a different socket. Why? Because this is a server socket, which means TCP socket, and the TCP socket is identified by not by only the destination port, by the 4 values: source port, destination port, source address, destination address. Okay? So that's why each 2 application endpoints, they need to have separate socket buffer. واضح؟ مش واضح.
I don't understand
أيوة.
the source port, they're the same for VP and
لا, this happens by coincidence, by the way. This is a good observation. It's good you observed that. So this is just by coincidence. And it might happen in reality, by the way, because this source port is assigned to this application endpoint by the operating system on this host. Okay? And this source port is assigned to this application endpoint by the operating system on this host. Okay? It might happen that they are the same or they are different. Doesn't mean anything. واضح? But here we are giving you the worst case scenario. Assume even that the source port is the same and the destination port is the same. Still, we have to create a separate socket buffer. Why? Because the source IP address and the destination IP address are different. And that's why the connection end-to-end has to be identified by these 4 values. Even if the 2 values are the same, okay, you have to have different IP address for source and destination. واضح؟
B5 and B6 are same for source IP address and destination IP address.
What? Sorry?
B5 and B6 for IP are same for source IP and DIP.
Yes, but different source port.
But different source port, yes, different source port.
But same destination.
ما same destination بس خلاص once one value in these 4 values are different خلاص it's a different connection.
It's in the
ما هو this is typical. 2 hosts, they can have 100 applications here and 100 applications here, they are communicating together. If it's using TCP, then each 2 applications will use different connection, which means different socket. Okay? So I can open 100 tabs on my host. Okay? All of them google.com. أنا حر. صح? This means 100 tabs from my machine will connect to google.com on port 80. Okay? But these 100 tabs, they have different source port. So there has to be a separate socket on Google for each of my tabs, for each of my 100 tabs.
So the client create this,
Sorry?
the client create the source IP and the destination or
لا, source IP is assigned to this host while destination IP is assigned to this host. الاي بي ادرس assignment ده حاجه ثانيه. اي بي ادرس assignment ده موال تاني خالص. ده في النتورك لاير we'll talk about that في النتورك لاير. Okay, but يعني the IP address refers to one host. Each IP address refers to the whole host يعني. ماشي. So as long as the source port is different, so we have different socket buffer on the source and on the destination. That doesn't mean that each socket buffer has to have a separate application. Okay? The example that we just mentioned, it's the same web browser but has 100 tabs, right? So we call this a threaded application. Okay? So you can have the same application, but it has multiple threads. Each thread will have a different socket, and of course different source port. ماشي؟ واضح كده؟ So this is called threaded web server or threaded application in general. ماشي؟ So any question so far? So this is the light part of the lecture. The remaining part of the lecture we talk about reliable data transfer. ماشي؟ For reliable data transfer بقى we have different levels of reliability that we need to provide at the transport layer level. Here we're talking mainly about TCP. يعني almost forget about UDP because UDP does not provide any level of reliable data transfer. Okay? But in network 1 we talked about one level of reliable data transfer and we told you that we have to use ACK and so on. But we need to here talk about the sequence, the thought process that any protocol designer can go through in order to design a sophisticated protocol like TCP. Because TCP is really sophisticated. Yeah. ماشي? So we need to talk systematically about what are the steps that we can have and what are the different levels for providing reliable data transfer. So the transport layer itself tries to provide some reliable data channel, okay, for two endpoint applications to communicate. That's what we're trying to achieve. That happen through the fact that we have underneath the network layer itself is inherently unreliable, which is the case. As we have studied in Network 1, IP is inherently unreliable. Okay, IP is best effort. Okay, IP is based on best effort. IP does not provide any acknowledgement or does not provide any guarantees that when you send a packet, it has to arrive on the other side. No. Okay? This means that the transport layer protocol needs to provide reliable data transfer over an inherently unreliable channel. صح كده؟ Okay? So here بقى, in order to do this, we need to have some logic here, okay, that despite the fact that the underneath channel is unreliable, I need to provide some guarantees on reliability. That's what we're trying to do, صح? This is what we are trying to achieve, okay? And the other challenge is that this unreliable channel is not only unreliable, and I don't know anything about it. I don't know anything about the network really. TCP, does TCP need to know that I'm working over wired or wireless? No. Transport layer protocol is inherently agnostic to the network access. Completely agnostic. It doesn't need to know anything about it. Neither the network topology, nor the physical topology, nor logical, doesn't need to know anything about that. Okay? So, yet I need to have some reliable data services over unreliable channel. Okay? So we have, when we receive segments, or when we receive information from the application layer, we need to perform segmentation and then take each segment and then call this function, which is reliable data transfer send. This reliable data transfer send needs to perform certain logic, okay, so that when it sends over the channel using unreliable data transfer send, that what I have done here compensate for the fact that this channel is unreliable. That's what we need to achieve. ماشي؟ طيب, how do we achieve that بقى? So this is what we're trying to do. We have reliable data transfer send, which is called from above. So this is an event. So any transport layer protocol will run as a process with some inputs and some outputs. Okay? The input is event based, is triggered from the application. مش عارف واضحة دي ولا أوضحها diagram. So the process of TCP is running. Okay? So it receives an interrupt, software interrupt, from the application layer saying, okay, I want to send this segment. So that's an event. This event will trigger this function, which is called from above. Okay? Then I need to do certain logic here, and then perform unreliable data transfer, send to the network layer, okay, so that this will be transferred over an unreliable channel. And what I have done here compensates for that, or provides some reliable data transfer. What I'm trying to say is that this RDT send is an event that's triggered from the application layer. Keep that in mind, okay? And also here, at the receiver side, I need to do the reverse operation. At the receiver side, I receive also a trigger called a reliable data transfer receive. Okay? Because at the receiver side also I need to facilitate the reliable data transfer with the sender. Okay? So this is an event, or this is triggered by an event. This is triggered by an event, and this is a unreliable data transfer send is a function that I call when I finish this logic. So when I finish this logic, I call this function to the network layer. So when I receive that trigger, I perform something here, and then I call this function to send it. Deliver data means what? Deliver the segment to the application. Okay, which means that everything is fine. خلاص, I received the segment. Everything is fine. خلاص, send the segment above to the application. Okay, so these two are triggered by event, and these two are functions that I have to call once I finish the logic. ماشي؟ طيب, so our tool to approach how to provide, so far we did not answer the question, and we're still trying to see how we can provide reliable data transfer over an unreliable channel, right? So this is our ultimate goal. Now, our tool is to use a finite state machine. ماشي? Finite state machine is one of the powerful tools, really, that's used to try to model a system, any system, using set of states. Okay? So any system, we can model this system in such a way that we say that this system is in state 1 or state 2 or state I at any point of time. ماشي? While I'm in state I, okay, I receive an event. When I receive this event, then I have to do certain actions. Based on these actions, I may transfer to another state, or I may actually go to the same state. So that's what finite state machine is in a nutshell, and it's a very powerful tool that's used in many, many disciplines. And I'm sure you have come across this, or you will come across finite state machines in one shape or form. ماشي? So now we need to step by step use finite state machine to try to derive or generate the logic that we need to do from the moment we receive an event from the application saying RDT send. Okay, we need to do something, okay, until we call the function UDT send to the network layer. Okay, so we need to find this logic using finite state machines step by step. Okay. Type. So we'll try to do that on different levels to really show you that reliable data transfer has multiple levels, not just one level. It's not binary. It has multiple levels. So we are trying now to find the logic for reliable data transfer 1.0. So that's a trivial case where we assume that the underlying channel is perfectly reliable. If the underlying channel is perfectly reliable, then really I don't need to do anything. خلاص, I don't need to provide anything. I don't need to have acknowledgement. I don't need to have anything. When I receive the RDD send, all I need to do is just to create the data, just add the header. And here the header is a source port, destination port. That's what I need to do. That's it. And then UDT send, that's it. And then I remain in the same state. I'm always in the same state. I'm not expecting the system to go in any other state because there is no possibility of error. Okay, there is no possibility of any adverse event that might happen. I'm always in the same state. So when I receive the trigger, I just send the data and that's it. And at the receiver side, all I need to do is just to extract. Extract معناه remove the header from the data and then send the data up. That's it. So extract data, deliver data up. Okay, so this is the minimum which is done in UDP. UDP does that. Okay? So this assumes, in that case, we have a very strong assumption that the underlying channel is perfectly reliable, which is not the case. طيب. If the underlying channel may actually have specific type of error, okay, which is it may actually corrupt the segment, but there's no chance the segment can be lost. فاهمين الفرق؟ Okay? So we have two types of errors that whenever we send a segment, the segment might get corrupted on the way. So that's one form of unreliable channel. صح? Okay? But that's the only possibility that can happen. Although in practice, the segment might get corrupted, might go into loops, might get lost. Okay, but let's take it step by step. So in that case, what we need to do is to account for the fact that there is a possibility of segment corruption, but there's no possibility of packet being lost. ماشي? If a packet, the difference here, because from a logical perspective, if a packet is corrupted or a packet is lost, for the transmitter, what is the reaction? I have to retransmit in both cases, صح? If I receive a packet and the packet is corrupted, or I receive a packet and the packet is lost, the end result is the same, but what is the difference? The difference here is that there is an event. A packet is received but in error. But if a packet is lost, okay, there may never be an event. And I have to somehow, okay, declare that I cannot wait for this packet forever. اللي هو بقى timeout. This is the main difference. Here, we will not find any discussion or any form of a specific timeout. Because I'm always expecting the packets to arrive. Always. Okay? But the only possibility is that the packet may have an error or may not have an error. ماشي? So that's the first level of unreliable channel. So here بقى, we can approach this problem from two possibilities really. So we can say that, okay, so if a packet arrives and it's corrupted, the receiver will send what we call a negative acknowledgement. Okay? If a packet arrives and it's not corrupted, then we send an acknowledgement. That's good. That's a good approach. Okay? That's one way of approaching the design of this logic now, is to use acknowledgement and negative acknowledgement. Okay? So that's easy. So all we need to do is just to check the packets. And how do we check the packets? We'll see that how to account for the packet corruption is to use what فاكرين field في الهيدر كنا بنستخدمه عشان you were using that particular field to know whether the packet has been corrupted or not. حد فاكر اسمه ايه؟ ايوه برافو عليك. ايوه checksum. Okay? So checksum is a field that I use to check whether a packet has been altered on the way or not. That's easy. Okay, so now, in addition to the source port and destination port, we need to have at least the checksum now. تمام. And now بقى I have to have two states. Well, that's one way, that's one possibility. I can have three states actually. One is to wait for packet to come from above, and at the sender side, I need to wait for acknowledgement. And I can create, actually, there are multiple ways where you can design the finite state machine. Maybe you can have a state here called wait for acknowledgement, wait for negative acknowledgement. You can do it this way, but here we choose to use two states only. So if the two possibilities are whether I'm waiting for a packet from above, so in that case, I send the packet, and here I make the packet, and as you can see here, we have in addition to the data, we have the checksum. Okay, this checksum is what I use to know whether the packet has been corrupted or not. واضح كده؟ Once I do this, I send the packet, and then I transmit to this state. This state is to wait for acknowledgement or negative acknowledgement. And hereby I have two possibilities. Here, whether I receive an acknowledgement or a negative acknowledgement. If I receive an acknowledgement, everything is good, and if it's acknowledged, then I received the acknowledgement correctly, which means that the packet has arrived non-corrupted on the receiver side, and the receiver side sent me back an acknowledgement, so that's perfect. So this means I will go back to here. And here, of course, forget about sending multiple packets back. I'll go back in. Yeah, we'll get to that. But here we're talking about only one packet. Only one packet. Okay? And the packet must arrive. It's just that we have a possibility whether it's corrupted or not. Because we will see later on, if the packet is lost, it's totally different. If the packet if we receive a negative acknowledgement, then all we need to do is to do what? Is to do retransmission. خلاص. Retransmit the packet. The packet is still in the buffer, so I don't have to. خلاص. The packet is still in the buffer, so I send the same packet, and I go back to the same state. And I keep retransmitting until the packet arrives with no corruption on the receiver side, and I receive the acknowledgement. That's it. That's easy. Any question here? واضح؟ لا خلاص ده بس for packet corruption. For lost packet we'll see that احنا هنا we didn't talk about sequence number either. There's no need for sequence number here, given the assumption that there's no possibility for packet loss. If there is a possibility for packet loss, we'll see that it will be more complicated.
The U and UDT is the abbreviation for
unreliable data transfer send. Yes. اللي هي معناها send through the unreliable channel. اللي هي network channel.
And why the packet is still in the buffer although it was sent already?
The packet, when I send a packet, I have to keep it in the buffer until I receive the acknowledgement. So if I receive negative acknowledgement, I take it again from the buffer and transmit it. So here you see that there is send data, but there is no make packet. خلاص the packet is already in the buffer. صح? So I don't have to make the packet again. I just need to take it from the buffer and send it. ماشي؟ طيب here on the receiver side, this is the receiver side. But on the receiver side, I receive one type of packet. I don't receive acknowledgement. In the receiver side, what I'm expecting is to receive the actual packet. And there are two possibilities: whether a packet is corrupted or whether a packet is not corrupted. If the packet is corrupted, I send negative acknowledgement. If the packet is not corrupted, I send positive acknowledgement. And these are the two states here. ماشي? If the packet is not corrupted, then I extract the packet, send it up, and send the acknowledgement. I do two things. I have to send the packet to the application, and then send the acknowledgement back to the sender. ماشي? And this is the logic. يعني based on a certain event, you can perform multiple actions. The actions are set of actions. Okay, it doesn't have to be one action. You can يعني هي كأنك بالضبط إيه؟ You have a function and you have steps in this function.
Because at sender, there is two states, one state for acknowledgement, but here just
Yes, because on the sender side, I send a packet and I receive different type of packet, which is acknowledgement. Acknowledgement is like a different type of packet. On the receiver side, here I'm expecting one type of packet only, which is the actual segment, or the actual packet that arrives. صح? Okay? So here, if the packet is corrupted, I just need to send negative acknowledgement, and that's it. Okay? And again, remember here, we don't have to deal with sequences, we don't have to مفيش أي حاجة. هي one packet. يعني معناها the channel the channel from one application to one application, this channel can actually have one packet at a time. That's it. Okay? Any question? ماشي? It's gonna get worse. If you have any question, you better raise it now. So that's the sequence. So if I wait for a call from above and I receive the reliable data set, the reliable data send, I make the packet and I send it, which will trigger either this or this. If the packet is uncorrupted, non-corrupted, معناها this is the happy path. I extract the packet and send it above, and then I send the application, send the acknowledgement. ماشي? So that's what I do. And here, if the send packet is corrupted on the way, then this will trigger this event that the packet is corrupted, in which case I send negative acknowledgement back. So this is just a, يعني, okay, yeah. It paused for a little bit. Okay. طيب. We will do one slight design change, that if the packet is corrupted, we said that we use acknowledgement and negative acknowledgement, right? So the sender doesn't know what happened at the receiver side, and it cannot just, so if the sender doesn't know that, can't just retransmit possible duplicate. So if the packet is lost, okay, the sender send the packet and the packet is lost, right? If the packet is lost, then the acknowledgement will not be sent on the other side. So there is a chance that the transmitter will retransmit the packet, okay, and there is a chance that you have duplicate packets. This is what this scenario is trying to say. So if the sender sends one packet, then waits for the receiver response, this is what we call in network 1 the stop and wait. ماشي? So we'll see how this works. So here we still have acknowledgement and negative acknowledgement, but here we have the case where the acknowledgement might get lost. Yes, so here we have the case that the acknowledgement is lost. So here we assume that the forward channel can only corrupt the packets, but the backward channel, okay, can corrupt also the acknowledgement and the negative acknowledgement, which means that when the acknowledgement arrives to the sender really doesn't know whether the packet has arrived in error or whether the packet has arrived at all. So if the acknowledgement is garbled or the acknowledgement itself is corrupted, this is actually equivalent to the fact that the packet might get lost, because I received the acknowledgement and the acknowledgement itself might get corrupted, which means I don't know whether this is acknowledgement or negative acknowledgement. So I don't know whether the packet arrived or not, in which case I may have to retransmit it. When I retransmit it, okay, there is a possibility that the packet has arrived with no error, so in that case the receiver will receive the packet duplicate, will receive the packet twice. Okay? So in other words, in the previous case, we assumed that the channel can corrupt the packet, but it cannot corrupt the acknowledgement. Okay? And that's on its own is a strong assumption, because if the channel can corrupt the packet, the channel can also corrupt the acknowledgement. Okay? Because channels are, we call it reciprocal channel. Reciprocal channel, if there is a specific behavior on one direction, okay, the same behavior might happen in the other direction. ماشي? So if the acknowledgement or negative acknowledgement can get corrupted, so that's what we talk about here. And in that case, we may have duplicate packets. صح? Once we have duplicate packets, we have to distinguish between these two packets. Okay? The only way to distinguish between these two packets is by using a sequence now. So this is the first case where we found that we must use some kind of sequence number. Why? Again, يعني graphically what happens is this is the sender and this is the receiver. Okay? It's the same packet being sent, okay? And it arrived here correctly. The receiver sent back acknowledgement, okay? Which, as we said, it arrived, but in error. Okay? If the acknowledgement is in error, I don't even recognize whether this is acknowledgement or negative acknowledgement. I don't know, right? So the only thing I could do is to do what? Is to retransmit the same packet again. Okay? Type. If you are at the receiver side, how would you know that these packets are duplicate or the incoming packet is a new packet? Right? So the only way you recognize the situation is by using sequence number. Okay? So we have to have sequence number. So that's the first thing we agree on. صح? طيب. Why do we have only 2 sequence numbers and not 3 and not 4? Okay? We only need 2 sequence numbers, 0 and 1, that's it. Why? Because the only possibility that we have is either this packet and this packet are different packets or they are the same packet. Okay? So if this is 0 and this is 0, duplicate. If this is 0 and this is 1, they are 2 different packets. Is there any other possibility? No. Why? Because again, here we're not talking about go back and we're not sending multiple packets at a time. We have to send one packet and then wait for the response before we send another packet. Okay? So in other words, the rule of thumb is that the sequence number always is 1 plus the number of packets that you can send at any time. Here, the number of packets that we can send at any time is only 1, right? Because of the possibility of acknowledgement being corrupted or a packet is lost, which is essentially the same, okay? You can have the situation that either duplicate packet or different packets. So that's why we need only 0 and 1 only. We don't need 2, we don't need 3, we don't need 4. ماشي؟ طيب. So we agree on that. And that's the first case where we started to see some sequence number, which will make the finite state machine more complicated. So here we have 4 different states. Okay? But the good news is, if we take like a cross section this way, okay, we see that the one above is a mirror of the one down. Okay, so this and this are the same. Yani it's the same but reversed. Yani. Okay, and this are the same, which is good news. Yani it's a repetition, but because of the fact that, as we said, we have 2 different packets, 0 and 1, the finite state machine has been more complicated a little bit. Mind you, you can just actually combine those 2 and combine those 2. You can still do it this way, but the event and the logic will be a little bit more complicated. ماشي؟ يعني there are multiple ways how you can approach a finite state machine. There could be multiple possibilities. يعني في الامتحان مثلا if I ask someone and he decided or she decided to combine those 2 and combine those 2, as long as you highlight everything correctly, that's fine. مفيش مشكلة. The most important thing is the logic. ماشي? So because again this whole thing was caused by the fact that the acknowledgement and negative acknowledgement may get corrupted on the way back. So the backward channel itself is also unreliable in the sense that it can corrupt the packets. ماشي؟ اتفضل.
عشان المفروض يكون second state هنا بتدي feedback للinitial state. هي هنا
Where?
بتكمل يعني لو افترضنا ان ده ستيت 1 ستيت 2 ستيت 3 ستيت 4 ستيت
لا.
2 دي مش المفروض تفيد باك ستيت 1 اللي بدات ولا
ستيت 2
لا اللي فوقيها انا اسف الايه مش المفروض دي تفيد باك
because if you receive acknowledgement for packet 0 you have to switch to packet 1 واضح because we're saying we have two sequences. Okay, there's no possibility you can receive acknowledgement for packet 0 and you go to wait for packet 0. No. فاهم قصدي؟ That cannot, that logic is wrong. ماشي؟ ماشي واضح كده؟
دي مترقمه
Yes, عشان السيكونس number, because of the sequence number. So when you receive positive acknowledgement, يعني it's not corrupted, and you receive positive acknowledgement for packet 0, then you have to switch to wait for packet 1. And when you do the same for here, you have to switch to 0. اتفضلي يا لا من 0 ل 1 ده different packet. من 0 ل 1 ده different packet. We're talking here about different packets. يعني معناها ايه؟ the sequence of packets for the previous cases I don't have sequence number. فخلاص I don't have to put numbers on the segments at all. Starting from here I need to have 0 1 0 1 0 1 0 1. So خد بالك the data here and here and here all of them are different, right? But the protocol itself guarantees the order and it only needs to have two sequences 0 and 1 0 and 1 0 and 1, and this will successfully guarantee the reliability of all the packets or all the signals coming from the application layer to arrive in order, okay, and they will arrive to the application in order, and the application will be able to recognize all these data and display the web page correctly and everything. given that our assumptions hold, which means that the channel can only corrupt the packet, but it cannot cause packet loss.
if acknowledgement for packet 0 does not come we are stuck in this state.
Yes, of course. That's here. And same here. اتفضل. Here. Huh? No, we start from 0 or 1, doesn't matter. We start from 0 or 1, doesn't matter. Let's say we start from 0. Here, waiting for packet 0 to arrive from the application. اللي هي دي. Okay, خلاص. We'll make the packet and we'll send. And when we send the packet, we put sequence number and checksum. We'll send the packet. The sequence طبعا. The sender will put the sequence number on the packet and then we'll send it. Okay. So once the packet is sent, the possibility is that from the receiver side we receive acknowledgement or negative acknowledgement for packet 0. ماشي? Okay. So when we receive the acknowledgement and it's corrupted, so here, we receive the acknowledgement, and the acknowledgement is corrupted or negative acknowledgement. Okay, if the acknowledgement is corrupted or negative acknowledgement, we stay in the same state. Okay, and we do retransmission. For both cases, we do retransmission. But the main difference here is that if the acknowledgement comes, I have to switch to packet 1. That's the main difference here. Any other questions? Any questions? So the main reason why we have the two sequence numbers is for the fact that the acknowledgements themselves might get lost. And this is the first stage where we don't know whether the packet has reached aslan wala la. So by retransmission, we may cause some duplicate packets, and that's what triggered the need for two sequence numbers. اتفضل.
I think you just answered the question.
Okay.
What if you sent a packet, it wasn't corrupted or lost,
تمام.
but the acknowledgement was corrupt?
Yeah. So if yes, exactly. That's the case that I'm talking about. So the packet arrived correctly, but the acknowledgement was corrupted. Okay. So the sender will not even recognize whether this is acknowledgement or a negative acknowledgement. So if the packet is corrupted or there is negative acknowledgement, I have to retransmit. But the problem here, this retransmission بقى, we'll see بقى what it causes on the receiver side. That's the key now. On receiver side بقى, if I'm waiting for packet 0 and I receive packet 1, صح? Should I accept it now? No. ماشي? I'm waiting now for packet 0 because packet 1 has previously arrived correctly. And now I'm in a state of waiting for packet 0. If you give me 1, I will not accept it. This is about the duplicate packet. Okay? If I'm waiting for packet 0, you should give me packet 0. There's no other way. Yeah? So if the packet is corrupted, if the acknowledgement is corrupted, I will retransmit. The problem here is that this may cause some duplicate packet on the receiver side.
If it's waiting for packet 0 and then that comes packet 1.
On the receiver side, خد بالك ده transmitter بس. I will get to the receiver. Okay, so we'll get to the receiver. This is only the transmitter. This is only the sender side. This is the receiver side. Receiver side is ايه؟ في حاجات كتير، في ورود وحاجات كده. Okay, because here, while I'm in one state, there are three possibilities. There are three possibilities now. إن هو first, a packet arrives and arrives correctly. Packet arrives and it's corrupted. Packet arrives and it has different sequence number. ماشي? So these are three possibilities.
Packet does not arrive.
لا ما فيش الكلام ده. No, this is packet loss. We didn't talk about that. We will talk about that next time.
Have the case that the receiver is receiving a packet with a different sequence number?
Yeah, here.
That is not expecting it. So that kind of stuck case, like the receiver is waiting to receive
A packet, yes, our receiver is waiting to receive packet 0, yet it received packet 1.
it's stuck.
لا مش stuck, هو it's going to reject it.
Yeah, but I mean like
Right.
at the other side we have the sender trying to send packet 1 and then it's waiting for the acknowledgement.
لا هي مش stuck. هقول لك ليه بقى. When I'm waiting for packet 0, let's say I'm waiting for هنا. This is the key that will break this deadlock اللي انت بتتكلم عليه. هقول لك ازاي. I'm receiving a packet. This is corrupted. خلاص. I will send negative acknowledgement. عادي. I'm receiving a packet and it's not corrupted, but there is sequence number is 1. I'm waiting for 0. Definitely I will not accept it. But I will take that as an indication that the acknowledgement that I have sent previously was not received by the other end. Okay? So I will retransmit the acknowledgement. Okay? I will retransmit the acknowledgement. And that's what will break this deadlock. Okay? Because here, this acknowledgement, hopefully this time will arrive, and will arrive not corrupted. Okay? In that case, the receiver will do what? Okay, we will accept the acknowledgement, and we'll switch the packet to packet 0, and that's what I'm waiting for. Okay? If it doesn't happen this time, it will happen next time. If it doesn't happen next time, it will happen the time after, and I will keep doing that. Okay? So every time I receive a sequence number that's not equal to the sequence number I'm expecting, I will reject it definitely. Reject it معناه ايه؟ I will not extract it and send it above. خلاص ما هو if I don't extract and send it above this means I'm discarding that packet صح؟ مظبوط؟ The packet لا the packet will be discarded. طبعا dropped. يعني معناها I will not send it above to the application layer. Okay? But I will send the acknowledgement again. I will send acknowledgement, not negative acknowledgement. I will send the acknowledgement because this means that packet 1, I had received packet 1 already. Okay, so I'm telling you that I received packet 1. Send me packet 0. So this will not cause any deadlock. So this will be sent to the sender. The sender will say, oh, okay, you received packet 1. Okay, so now I need to switch to packet 0. And that's what I'm waiting for here. Okay? Logic is getting more complicated. Listen. There is another 2-3 levels of complications. Yeah, if the packet if the packet is different معناه ايه؟ يعني I'm waiting for packet 0 yet I'm receiving packet 1 خلاص I will reject it. I will not send it above and I will send the acknowledgement. If the packet is 0, okay, if I'm waiting for packet 0 and I receive packet 0 خلاص I'll do everything, extract, deliver above, and then I will switch to packet 1. نفس الشيء اهي I'm waiting for packet 1 I receive packet 0 I will do the same. هي ما هو هنا برضو الميرور هنا برضو متحققه هنا برضو في ميرور. يعني هو again this mirror came because of what? Because of the fact that the possibility of corruption for the acknowledgement may lead to the duplicate packets. Okay? Because of these duplicate packets, I need to distinguish between only 2 packets. Okay? So in order to distinguish between 2 packets, I need to see 2 sequence numbers, 0 and 1, that's it. أي لبس أي حاجة يعني it's gonna get worse. We didn't talk about the packet loss until now. كل ده we didn't get to the packet loss. So again the here اتفضل there's no number لا ما هو again here the assumption that's a good question. Yes the assumption here is that we need to provide unlimited reliability over a certain type of unreliable channel. Unlimited reliability بقى معناها ان احنا we will keep trying forever. Okay? And that's one of the drawbacks of TCP, really. We will talk about that when we get to the analysis. This is one of the drawbacks of TCP. Okay? Because sometimes 100% reliability is perfection. Okay? It's like you're trying to achieve perfection. But for some application, it's a requirement. يعني قلت لي مثلا I'm sending مثلا zip file. Okay? And one packet gets lost. I'm sending one 10 gigabyte zip file and one packet is lost. معناها 10 gigabytes are useless صح؟ فهنا 100% reliability is a must. It's not a joke. So this unlimited reliability in that case is needed. There's no way around it. Okay, but if we're talking about video, that's another story بقى. And that's why TCP has never been very efficient when it comes to video streaming مثلا or video on demand and so on. طيب, so here we have 2 sequence numbers which is sufficient because of the fact that we only have to distinguish between 2 packets, whether it's the same packet or 2 different packets. That's it. And those are the 2 possibilities. We don't have any third possibility. And must check if we received acknowledgement or negative acknowledgement. Okay? And we have twice as many states because of the fact that يعني الحكاية الميرور اللي احنا عملناها دي we need twice as many states because of the fact that we need to distinguish between 0 and 1. And here we must check if the received packet is duplicate. And here the state indicates whether 0 or 1. 0 كل حاجة 0 or 1. طيب ماشي. So that's another tweak here that we could do is to ask ourselves, can we actually remove negative acknowledgement? This is like يعني 2.2 يعني this is like a one يعني upgrade, one small upgrade. Instead of sending negative acknowledgement, can we indicate negative acknowledgement without really sending negative acknowledgement? Okay? Can we do it in another way? Because then we can simplify. يعني, instead of having acknowledgement and negative acknowledgement, because these are two different control messages. Okay, so we can have one message only. Okay, but we can indicate whether a packet has been corrupted, arrived corrupted, or not corrupted. Okay? We're talking about this here, why بقى? Because of the possibility that the acknowledgement might get corrupted, we have duplicate packet. Okay? So if we have a duplicate packet, as we said, that we send the acknowledgement of the previous packet to indicate that the previous packet has arrived correctly. ماشي? So if a packet arrived corrupted, okay, instead of sending negative acknowledgement that this packet is corrupted, I will send positive acknowledgement that the previous packet has arrived. Which is يعني the same concept يعني. So this way I can get rid of negative acknowledgement altogether. So instead of telling you negative acknowledgement, this packet has arrived corrupted. لا, what I will tell you is that the previous packet has arrived successfully. If you receive an acknowledgement and the acknowledgement is not what you are expecting, you will take that as a negative acknowledgement. But indirectly, يعني implicit negative acknowledgement through the use of acknowledgement. ماشي? It's getting a bit confusing. طيب, here, what we will try to do is that we will take one part of the mirror, يعني. We'll take only one part, and this is the sender, and this is the receiver. ماشي? And here the sender, for the happy path عادي, هنا بقى this is what we need to do. If I receive at the sender side here, there is no possibility of receiving negative acknowledgement, as you can see. ماشي؟ مفيش هنا I'm waiting for acknowledgement. And I'm waiting for acknowledgement of 0. ماشي؟ If I'm waiting for acknowledgement 0, and then I received acknowledgement, okay, 1. This receiving acknowledgement 1 for me is equivalent to sending negative acknowledgement for 0. ماشي? So this way I can get rid of the negative acknowledgement altogether. Which corresponds to here. So here, if here, so if the received and the packet is corrupted, this is the. So here, if I receive the packet and the packet is corrupted, this is at the receiver side, ماشي? And the packet has a sequence number of 1. So this is straightforward. So in that case, I will discard the packet. I will not send it above. And then I will send the acknowledgement back to the sender. ماشي? طيب احنا we need the case that the packet is corrupted. So here, yes, so here بقى if the packet is corrupted, this is the only change. If the packet is corrupted, I will send the acknowledgement for the previous packet. If the packet if the packet is received and if the sequence number is different, I will also send acknowledgement back to the sender. So in both cases, okay, I didn't use here negative acknowledgement at all. So if the packet is corrupted and the packet even has the same sequence number, I will send acknowledgement, not negative acknowledgement. Here I will send acknowledgement back to the sender. Okay? And if the packet arrived successfully and the sequence number is 1, I will also send the acknowledgement. So the main difference here is that instead of sending negative acknowledgement, I will always send the acknowledgement for the previous one. واضح? Which will, this one will trigger this one. Okay? I received an acknowledgement, but the sequence number is not what I'm expecting. So I will take this as negative acknowledgement. Okay? So this is يعني a small upgrade. So the only thing I achieved here is, and this is actually what happens in TCP. TCP does not use negative acknowledgement. Okay? But again, we're trying to take you through the thought process where the protocol designer might actually think about how to develop the protocol step by step. So at the beginning, you might come up with a solution, okay, and then you improve it. You keep improving it. So definitely, if you have acknowledgement and negative acknowledgement, this will increase the overhead because you have multiple control messages. So instead of doing that, you get rid of negative acknowledgement by sending the acknowledgement of the previous packet. Okay? So that's essentially the same. Okay? So that's what we achieved here. Now we need to talk about packet loss. So here for packet loss, the packet might get lost, acknowledgement might get lost. So the main difference here, the main difference here is that the packet may never arrive. Okay? So what is the extra factor that we need to keep here? Ahmed, as you mentioned before, Loa, bravo, time. Here بقى we need to talk about time. Because time out بقى إيه? The packet may never arrive. Acknowledgement may never arrive. Okay, so that's what we need to think about. خلينا نبريك ولا لسه؟ لا خلينا نبريك. طيب, as we said, the slight difference between packets or acknowledgements arrive, but there is a possibility of corruption, and packets that may be completely lost. The main difference here is that the packets always arrive, which will generate the entrance. Okay? But here, if the packet or the acknowledgement are lost, you may wait for something that may never happen. So the only way is that you have to wait for a reasonable amount of time. شوف reasonable دي بقى مهمة جدا. We'll see بقى why a reasonable amount of time. This is the main factor that we will analyze later. Because really this timeout is very critical. Very critical. We'll see بقى how TCP calculates this timeout. It's very critical. ماشي? So after this time elapses, you need to retransmit. Okay? You assume that there was no acknowledgement or the packet is lost, in which case you have to retransmit, whether again the packet or the acknowledgement. And for that purpose, you need like a countdown timer. Like when you fire a packet, you have to fire a timer, count down, okay? During this time, you are expecting the acknowledgement to come. If the acknowledgement never comes back, then you assume that either the packet was lost or the acknowledgement was lost. And for you, it's the same. For the sender side, it's the same. You have to retransmit. For the receiver side, it's different. Because this may actually cause some interesting scenarios that the packet might be duplicate. Also here, the packet might be duplicate. But duplicate, we have resolved that using the sequence number, صح? We have 0 and 1, الحياة ماشية, مفيش مشكلة. Okay? But here بقى we may have a very interesting scenario بقى, which يعني ايه, it did not happen before. Very specific, and this will distinguish really the implementation of the finite state machine. This scenario happens as follows. So the sender sends the packet, okay, to the receiver, and the receiver receives that packet, okay, and sends back the acknowledgement. Okay? The sender was waiting for some time. Okay? Assume that this acknowledgement goes through the network. وبعدين ايه يعني the acknowledgement meets a friend, so he started to talk to him. يعني got a little bit delayed for some reason. Okay? So the sender waited for some time, and the timeout has elapsed. Okay? May happen. That's why this reasonable timeout is really critical. So here, what is the assumption? Packet was lost or acknowledgement was lost. So what do? I will send the same packet again here. Okay? And then after I retransmitted the packet, I received the acknowledgement. Okay? In that case, this is a retransmitted packet, and this acknowledgement was for the first time I sent the packet. Yet for me, when I send the packet, I will wait for acknowledgement. Acknowledgement got delayed, okay? So I will accept it. صح? طيب, what will happen بقى? Another interesting thing. When the receiver receives the duplicate packet, what will it do? It will send another acknowledgement. This is the interesting scenario that it did not happen before. So this scenario happened because of the fact that we are using a timeout. And the timeout happened to be premature or not carefully calculated. Or the acknowledgement got stumbled on the way back. Okay? So this is what we say delayed. The acknowledgement was not lost, but it got delayed. So here I will receive duplicate acknowledgement for the same packet. One I will accept it, and the other one will come later. And we'll see how this is reflected on the diagram.
Did we say that if the receiver receives the duplicate packet, it will discard it? So why did it send an acknowledgement?
ما احنا قلنا بقى we have to always send an acknowledgement. لان انا هفترض ان هو acknowledgement the first time was not received successfully by the sender, and that's why he sent me another packet. Okay? فاحنا قلنا خلاص احنا will send an acknowledgement for the packet that we are trying to that we received successfully. Even if we receive a packet corrupted, I will send an acknowledgement for the last one that was received successfully, to avoid the use of a negative acknowledgement. صح? This is what we do. ماشي? Any other questions? So is actually this one is the second acknowledgement. So the first one I will accept it, right? But this second one, it's weird. It's not supposed to happen, but it happened. And that's one possibility why something like this happened. Because of the premature timeout. ماشي? Or the acknowledgement got delayed. So this one I will accept it, and I will move to wait for packet 0 or wait for packet 1. While I'm waiting for packet 0 or wait for packet 1, I receive the packet from below saying, oh, okay, here is another acknowledgement. I'm not expecting that event to happen, but it may happen. So we'll see now. أولاً طبعاً there's no negative acknowledgement, as we said. We got rid of that. So every time we receive corrupted packet, okay, So we will send an acknowledgement for the last time, the last one that was received successfully. The interesting thing here, we see like lots of similarities. The main thing here that happened is this weird event. This weird event here. طبعا here we have like the concept of timeout. So whenever I send a packet, the main thing here is that I have to start a timer. So this timer has a mechanism. It has to start whenever I send a packet. So here I have to send a packet, or if I'm waiting for, I retransmit the packet, also I start the timer. So whenever I retransmit or send a packet for the first time, I have to always start the timer. When the timer here, I might have an event that the time out has elapsed or the countdown timer has reached 0. In which case, I will have to retransmit and also start the timer. Okay? So this is clear. When do we stop the timer? We stop the timer if we received the packet successfully. خلاص? So in that case, I stop the timer. And the acknowledgement is the one that I'm expecting, so I stop the timer. So these are clear, logical. What's not logical is this one. Why? Because this assumes that while I'm waiting for a packet from above, I receive the packet from below. I'm in a state that I'm waiting for a packet to come from the application layer, okay? But I received a very weird event. There's a packet coming from the network layer, which indicates what? Acknowledgement. Okay? That's a weird event. We never had to deal with that event before. And this is exactly what I'm talking about in this scenario, that this is not the first delayed acknowledgement. This is the one for the duplicate packet. Okay? Because while I'm actually I'm trying to wait for acknowledgement 0 to come, okay, I received the acknowledgement 0 and it's not corrupted. Okay, so this acknowledgement might be the delayed one, and I actually sent this as a retransmission, and I received the delayed acknowledgement. So in that case, I will accept it. Okay, so accepting means that I will come here. Okay, so I will come here. After some time, I will receive another acknowledgement. So I don't have to do anything. So this is this one, and that's why we have to we do nothing. This is like phi. We don't have to do any action. We just ignore it and move on. Other than this, the timeout is. This shows you how critical this timeout is. This timeout is really critical. Calculation of timeout has to be done very carefully. Why? Because if it's if it's premature, a scenario like this might happen. Okay, and if it's too long, we are wasting we are wasting like the channel, because we have to wait for a very, very long time before we do retransmission. Okay, so this leaves the channel empty for a long period of time. Should I wait for a short time or long time? Neither. You have to estimate it carefully in such a way that it's on the boundary. So if the acknowledgement was lost, you discover this as fast as possible so that you can retransmit and move on. If it's too long, you're wasting chances of transmission. If it's too short, you are causing duplicate packets. And in both cases, you are wasting the bandwidth on the channel. واضح كده؟ واضحة المثلين دول؟ So we don't need both extremes of too long timeout or too short timeout. We have to have some trade-off. There is an optimal point يعني. But the problem is this optimal point is based on so many factors, whether بقى the packet is congested or not. ماشي يعني the delay that's encountered by the acknowledgement varies. ماشي. And remember, TCP tries to estimate that timeout without knowing anything about the network. How can we do this while we don't have any information about the network? Okay? So that's why TCP has to use a mechanism to estimate a good, not optimal, because TCP does not use any optimization خالص. A good, reasonable timeout where it's not too long and it's not too short.
I know the receiver received the packet, it will send acknowledgement in the bottom packet. It will drop one of them, right?
Yes, of course. It will drop what? The acknowledgement?
No, the duplicate packet.
Yes, of course. First one will be accepted, sent above to the application. Second one will be ignored. But in both cases, I'll send the acknowledgement. We agree on that one. ماشي كده. Any other questions? واضحة النقطة دي؟ Okay. So finance estimation is good as I said as a thought process, as a way to design. بس يعني the timing diagram is easier to follow يعني. So this timing diagram shows some of the scenarios that we talked about. So if we have a sender and receiver, we send packet 0, we receive acknowledgement 0. So الحياة حلوة. This is a happy path. Everything is fine. مش أي مشكلة. Okay. This scenario talks about the fact that packet 1 was lost. So of course, if packet 1 was lost, I will wait for timeout. I will retransmit packet 1. Again, straightforward scenario. So nothing is really critical here. So I send packet 1. Of course, packet 1 did not arrive to the sender. ما فيش duplicate packet هنا. There's no duplicate packet or anything. So the receiver will accept packet 1, will send the acknowledgement, and then we'll move on. So there's no issue here. Here, this scenario, the packet arrives, but the acknowledgement was lost. And here the difference is the receiver will detect the duplicate packet. Through what? Sequence number. Okay? Because here packet 1 arrived, packet 1 here is duplicate, so I will ignore this. This one will be sent to the application, this one will be discarded, but in both cases I will send acknowledgement. So here I'll send the acknowledgement, here I'll send the acknowledgement. This one was lost, this one hopefully will arrive, and then we'll move on. So the only difference here is the duplicate packet, which was detected easily using the sequence. So this is the case of delayed acknowledgement. That's the scenario that was caused by the premature or incareful estimation of timeouts. So if the timeout is a little bit short, the packet will arrive and the acknowledgement might get delayed. Here, this acknowledgement will be accepted, even though logically this acknowledgement is for the second packet 1. Okay, but for me I don't know. So this acknowledgement is for packet 1, so I will accept it, even though it was delayed. But the fact that packet 1 was sent, okay, there is another acknowledgement 1 that will be received. And here, remember, here once I send, I'm waiting for this acknowledgement. So I'm trying to send another packet. So if this acknowledgement arrives, I'll just ignore it. Again, هو محلول. بس the problem here is what? The problem here is not there's nothing wrong. The protocol will work just fine. But the only cost here is what? Is waste of bandwidth. صح? Because I'm sending packet 1 twice. And if I had waited for another 2 milliseconds, I would have accommodated this acknowledgement without having to send packet 1 again. I would have avoided retransmitting packet 1, because retransmitting packet 1 is a waste of bandwidth. واضح هنا? This is the cost that I had to pay because of the incareful estimation of timeout. تفضلي.
Maybe it match the type of
مفيش نيجاتيف اكنولجمنت هنا، ما بتكلمش عن نيجاتيف اكنولجمنت.
For acknowledgement, for example, acknowledgement zero.
اها
If it's matched at the same time for acknowledgement zero, and it will consider as acknowledgement one, but it's not zero. And then
يعني if they arrive at the same time يعني اوكي ماشي. مفيش حاجه اسمها at the same time because I will receive them in sequence. Those are two different packets. For me they are two different packets.
because it's late, so it will
Hmm?
come.
Yes, it may be late and it may arrive here, but مفيش حاجه اسمها at the same time. This is one acknowledgement and this is one acknowledgement. I will receive this one first and then this one.
And the
ماشي.
first
If I receive packet 0, if I receive the acknowledgement for packet 0, okay, here packet 0 was sent, so I will accept it, no problem. If after some time this packet acknowledgement for packet 1 was received after packet 0, I will just discard it. In both cases I will discard it, ماشي. But the main issue here is for the duplicate packets causes some kind of bandwidth waste. This is the key here. And that waste was caused by the estimation of the timeout. طيب. كل ده بقى احنا بنتكلم على stop and wait. We did not even talk about يعني هنا logically there's one packet, there's supposed to be only one packet on the channel. I send one packet and I have to wait for the response before sending another packet. This is what we call a stop and wait. ماشي. There's another version بقى called go back in. We'll talk about it. But first, all what we have talked about now is under the stop and wait. For stop and wait, I send one packet and I wait for the response. So definitely the protocol is 100% reliable and it accommodates all practical errors of the channel, including packet corruption, packet loss. ماشي ده كله كويس. It works. But the performance, let's analyze the performance. The performance itself is not really good. Why? Because the channel, because we're sending only one packet at a time on the channel. Okay? So the channel is being used, okay, during the transmission time of that packet only. Okay? Other than this, the channel is not being utilized. So in order to emphasize this notion or highlight this notion, we will come up with a metric, okay, to estimate the utilization of the channel. The utilization of the channel. Okay? And to highlight this graphically, let's say like this is the sender and this is the receiver. So when I send one packet, what will happen is that the packet will be sent so that this length accommodates the length of the packet during transmission. In other words, this is the transmission delay or delay for transmission. This is the transmission delay, which is estimated or calculated easily. We know that. Lower length of the packet divided by the bandwidth of the channel. Okay? طيب, what is this time بقى? ليه أنا رسمت why did I draw the packet diagonal and not straight? ليه؟ لا. No. So when the packet arrives here, the receiver will send the acknowledgement. The acknowledgement will go back to the sender. But why am I drawing diagonal and not straight? Because the packet has to propagate over the channel. So this is in fact the delay for propagation. Because transmission is the time that I take to convert the packet on the channel from binary to a signal to be مش احنا قلنا كده المرة اللي فاتت؟ We talked about this last time, صح? So this is the transmission time. After I convert it to an analog signal, or a signal, any type of signal, it propagates over the channel, صح? As a signal. Okay? So this is the propagation channel, and this propagation channel includes بقى خلاص راحت بقى الراوتر والراوتر عمل processing وده السويتش والسويتش عمل يعني so many things happen. Okay? So this is the time that the packet will take to propagate over the network. Okay? And then once it arrives near, I have to do the same for the acknowledgement. But acknowledgement usually has no data, and that's why we write it only, we draw it only one line كده يعني, لأن هو it doesn't have data length. It's almost the length is almost zero يعني. So we care only about the propagation for the acknowledgement, but not the transmission time. Transmission time is nothing. Okay? Type. So from here to here, that channel was in fact utilized here. Ah? Okay? So, but what is this time? This time is the transmission delay plus the propagation delay for the packet plus the propagation delay for the acknowledgement. واضح? Okay? So during this whole time, I utilize the channel effectively only for the duration of transmission. Okay? هتقولي يعني, do you have any other choice? Yes, we do have other choices. So we'll talk about another alternative in a minute. Okay? But this is how we calculate the effective utilization of the channel. So this effective utilization is measured by calculating simply the transmission delay and the propagation. So propagation delay in this example is being given. Any packet goes from one side to another, it takes in total 50 milliseconds. Okay? And this is a motivational example, and you will see here that we're using 1 gigabits per second, so the transmission delay is actually almost negligible. عشان احنا we're trying to give you a motivational example that really the utilization is actually 0.027% of the time. That's an extreme example, which tries to say that if you have a really high bandwidth link, okay, the performance for stop and wait would be really bad. Would be really bad because you are using the channel only during the transmission, while the propagation takes a very, very long time. So the transmission time is really 8 microseconds, whereas the propagation time is 15 milliseconds. So here in the denominator, you have to calculate the round trip time, which is a round trip time is 2 times the propagation time, which is 30 in that case. Okay, so it's 30 plus the 8 microsecond, which is 30.008. So that's why this utilization is the transmission over 2 propagation plus the transmission. Yeah, 1 propagation, 2 propagation plus the transmission. واضح دي جت ازاي؟ واضح ولا مش واضح؟ Because of the propagation time for the acknowledgement. Because I cannot send any other packet until I receive an acknowledgement. Now this is the protocol that we have worked on so far. Now we didn't know any better protocol. Okay? So according to what we have designed so far, that we can send one packet, wait for acknowledgement before we send another packet, this is the performance we got in terms of channel utilization. Is that good? Of course it's bad. It's terrible. So it works. It works, but the performance is really bad. This motivational example tries to tell you, like, try to be smart about it. We don't really have to wait for the acknowledgement before we send another packet. Because during this time, if we try to transmit another packet, 1 or 2 or 3, then any number of packets that we will try to send during this time will actually multiply and will increase the performance. Okay? So this is this is the stop and wait. This is what we're trying to measure the performance for. So this is the transmission time, and this is the round trip. Round trip معناه إيه? 1 propagation time for the packet and 1 propagation time for the acknowledgement. So that's what we got. So now بقى, life is more sophisticated really. We cannot afford the fact that from one part of the world to another part of the world. يعني مثلا واحد in China is communicating with someone in Brazil, okay, and they have a channel or a connection end to end. There is one packet only going back and forth. This is what we have achieved so far. صح? This logically means that there is one packet at a time on this whole channel. يعني I created, يعني this whole channel is only for one packet going back and forth across the entire world. طبعا that's not efficient. What we would hope to have is something like this. Okay? That's what will enhance the performance. Can we achieve this? Yes, of course. This is what we call go back in. Go back in tries to say, okay, so instead of having to wait all the time before sending other packets, let's just send. But this will sophisticate the performance now, of course, because first of all, now I have to have a sequence number more than 0 and 1. I have to have other sequence numbers. صح? Now I have to distinguish between this one, this one, this one, and if there is any duplicate packet in any of them. Okay? So any of them might be duplicate, and I have to distinguish between one of them. So again, the rule of thumb is I need one extra sequence number, okay, plus the number of packets that I'm trying to send at the same time. يعني if I have n, then I need to have n plus 1 sequence number, which includes the stop and wait, because in stop and wait we have only one packet. We need 2 sequence numbers, صح? So if we need n packets, we need n plus 1. So we start from 0 and we end at n, which gives us n plus 1 sequences. واضح كده? So any number of packets that we can send at the same time will be multiplied at the numerator and will multiply the performance على طول. So that because the channel has been utilized all this time, okay, while in the denominator we still have round trip time plus 1 transmission time. So we have utilized the channel 3 times the performance of the stop and wait, or 4 times, or so we can have n different packets. ماشي؟ مفهوم كده؟ واضح؟ Any questions? طيب, so go back in بقى يعني طبعا is a big خلاص يعني عشان كفايه كده. So we'll stop here because go back in is another level.